Welcome to The Explainer. Today, we're diving into a really clever solution to a massive billion-dollar problem in the crypto world. We're talking about how to make it fast, cheap, and scalable enough for, literally everyone to use. So let's break down what this problem really is and how, believe it or not, a simple bar tab holds the key.
Okay, so this is the problem right here. Take a look at this chart. It shows transaction fees on a blockchain. And yeah, just look at those insane spikes. At times, a single simple transaction could set you back over $100 and take forever to go through. This is the fundamental bottleneck that stops a blockchain from being used for everyday stuff, like, say, buying a coffee.
And the solution, you're not going to believe this, can be understood with a metaphor we all get, a bar tab. Right? You and a friend, you open a tab, you go back and forth all night, and you only settle that one final bill at the very end. That simple idea is the key to everything we're about to talk about.
So, to really appreciate why this solution is so brilliant, we first have to get our heads around the sheer scale of the problem we're trying to fix, and it really is a billion-dollar problem.
What's so wild is that this wasn't some kind of surprise. This quote you're looking at is from the very first reply ever sent to Bitcoin's creator, Satoshi Nakamoto. From day one, from the literal first response, people knew that scaling was going to be a huge, huge hurdle.
So why does this even happen? Well, think of a blockchain like a highway with only a few lanes. There are only so many slots for transactions in each new chunk of data. When traffic gets heavy, when demand surges, everybody gets into a bidding war for those precious few slots. And of course, the tolls, the fees, they just go through the roof. It's a fundamental bottleneck baked into the design. Which brings us to the big idea, the solution, finding an escape route, a way to get off that congested main highway and do our business on a side road, taking things off-chain. And this is what we call a payment channel. It is our bar tab. Let's say Alice and Bob want to send money back and forth. They do one transaction to lock up some funds on the main blockchain. After that, they can transact privately between themselves, instantly, as many times as they want, for basically free. Then, when they're all done, they post one final transaction to the blockchain to settle up. That's it.
So, how do you set this up safely without having to trust the other person? Well, first, Alice funds the channel, locking her coins into a kind of shared digital vault. But, and this is crucial, before she does that, she gets a pre-signed refund from Bob. This is her insurance policy. If Bob just vanishes, she can use that to get her money back after a certain amount of time. Once that safety net is in place, she can start spending.
So this right here, this is the first step, the transaction to open the channel. It's public, it gets recorded on the blockchain, and it moves Alice's coins into that shared account. This is literally like putting cash behind the bar to get the tab started.
And this is where the magic happens. Every single time Alice pays Bob, she just creates and signs a new little receipt that updates their balances. She just hands it over to Bob. None of this touches the blockchain. These are just private promises exchanged instantly. Bob just holds on to the latest one because, well, that's the one that gives him the most money. And that's the number to remember, 2. Alice and Bob could make thousands, even millions of little payments back and forth, but only 2 transactions ever have to touch that slow, expensive main blockchain, one to open the channel and one to close it. It is a ridiculous efficiency gain.
Okay, but that was a simple one-way street. What if Bob wants to pay Alice back? And more importantly, how do we make absolutely sure that nobody can cheat? This is where things get really, really genius. This is how you transact without trust. This is the key question, right? If they're just swapping these updated receipts, what's to stop Bob from being sneaky? What stops him from trying to cash out an older receipt from earlier in the night back when he had more of the money? The solution is this absolutely ingenious cryptographic trap. It's called a revocable transaction. And think of it like this. Every single time they update the tab, they also trade a secret key that makes the previous balance totally invalid. It's like handing over the self-destruct code for the old state of affairs. Here's how that actually works. When they move to a new balance, say from state 1 to state 2, they exchange the revocation key for state 1. So if Bob tries to cheat and broadcast that outdated state 1, Alice now has the special key for it. And that key lets her immediately take all of the money in the channel as a penalty for him trying to cheat. And that is the aha moment. It's brilliant. Cheating isn't just stopped. It's made catastrophically financially devastating. The threat of that penalty is what enforces honesty. It's a financial self-destruct button that means everyone has to play fair. No referee required. Okay, so we've figured out how to have secure, trustless channels between two people. That's cool. But the real power, the real game changer, is when you start connecting all of these channels together into a network.
So think about this. What if Alice wants to pay a third person, let's call her Carol, but she doesn't have a direct channel open with her? Well, as long as Alice has a channel with Bob and Bob has a channel with Carol, she can just route the payment through Bob.
This works with another clever trick called a hashed time lock contract, or HTLC. Now, I know that sounds super complicated, but the idea is basically a trustless chain reaction. It works like this. Carol makes up a secret. She gives a cryptographic clue, the hash of that secret, to Alice. Alice then locks a payment to Bob and says, "Hey Bob, I'll pay you if you can tell me the secret that matches this clue." So Bob makes the exact same offer to Carol. Carol tells Bob the secret to get her money, and now Bob has the secret so he can go back to Alice and claim his money. The payment just hopped from Alice to Bob to Carol, and no one had to trust anyone along the way.
Now, just zoom out for a second. Imagine that little chain from Alice to Bob to Carol, but multiply it by thousands or even millions of these interconnected payment channels. What you get is a huge, sprawling, decentralized web for instant, near-free payments. And that is the Lightning Network.
But this technology, this whole idea, is so much bigger than just making payments faster on one network. So let's pull back and look at the even bigger picture for a second. I mean, we've all seen the headlines. For years, the crypto world has been rocked by these devastating collapses of centralized companies, exchanges like Mt. Gox, or more recently, FTX. People trusted these middlemen with their funds, and when those middlemen failed, hundreds of thousands of people lost everything. It's the classic problem of having to trust a third party. And this same technology gives us a direct solution. That same secret handoff trick we just talked about, the HTLC, it can work even if the channels are on two totally different blockchains. This enables something incredible called a cross-chain atomic swap. It means Alice can trade her Bitcoin directly for Bob's Ethereum, peer-to-peer, with absolutely no exchange in the middle that she has to trust.
So that's what this all leads to. When you put it all together, the technologies we've just walked through creates a way to have instant, global, and truly trustless transactions for pretty much anything of value. So the question I want to leave you with is this. If you had that power, what's the one thing you'd want to build?